Okay, now what we're going to do now is we're going to take this data that we've gotten and we're actually going to start doing some manipulation with the data. We're actually going to see what the data does. Alright, so for the first thing we want to do is I actually need to figure out what the constants were that I had. I also noticed that one of the things that Josh did is he put in inches and he did fractions. We probably want to change those into decimals. Alright, so let's talk about how this is going to work. Alright, first thing I want to do is the first thing we want to do is we want to actually put in what our constants were. Alright, we had this at a constant temperature of 300 degrees Kelvin. We had 100 heavy particles and 100 light particles. And actually, one thing I do probably want to do is I want to make sure it's the temperature that was at 300 degrees Kelvin. Alright, so we want to have all that information down on the spreadsheet so people looking at the spreadsheet who weren't in the lab will know what we did. Now, the next thing we want to do is we want to actually re-enter the data. Now, I am going to tell you something. This was not my intention, but part of the problem is when you set up the form, you have to be very careful to how you're going to get the data in the form. And the form didn't come through the way I was, the data didn't come through the way I was hoping it would, so it kind of messed things up a little bit. All right, so let's just put the data back in. All right, we have length, which was measured in actually not inches but centimeters, so that label is actually wrong. Pressure, which was measured in atmospheres. Okay, for this first one here, you got a pressure of 1.8 atmospheres at 3.28 inches. And then finally, we need to calculate volume. See, length is not volume. Volume, in this case, because I'm going to assume it was a square container, was length times width times height. Alright, so that length is not really accurate. Okay, that's only the length. Alright, so we're going to talk about how we're going to do this. Alright, so the first thing I want to do is I want to put in the length, which I have, and again, I'm going to convert the length into centimeters, which is what he was measuring. Pressure in atmosphere, volume in cubic centimeters. And then 3.5 is actually 3.5 centimeters. 1.8 is the number of atmospheres. All right. Now, what I'm actually going to do is I'm actually going to put all the rest of the data in. Okay, so 5 inches, 2 inches. Again, these are all centimeters. 9 centimeters, 6 centimeters, 7.25 is 7 1/4, 6, 7. Okay, actually that is supposed to be 7, not 7.25. Oh, looks like I duplicated myself. Okay, so this is supposed to be 7 1/4, 6. There we go. 7, 3 1/4. You can't see these coming in, but they're off the screen for you. All right. And then what we're going to do is we're actually going to start putting in all the atmospheres. Now, one thing I would like you to notice about the pressure that we're putting in is all what you should notice is that as the pressure increases, the volume or the length decreases. So, for example, we've gone from this to this. We've almost doubled the pressure, and what do you know? The volume is decreased by half. So actually, I want to show you how would you calculate volume. Well, we need to make an assumption. I'm going to assume that cylinder is a steady height. It's 6.6 centimeters in height. So I'm going to type equals, and I'm going to assume the height and the width are the same all the time. And we're only varying the length of the container. So I'm going to assume the height is 6.6 times the depth, which is also going to be 6.6. And again, I'm making these numbers up because I need to come up with a volume. And then the length of the thing is 3.5. All right. So my thing is 6.6 times 6.6 times. And again, I'm not going to plug in a number. What I'm going to plug in is this number right here, B1. Okay. So we know its height and its width is 6.6 times 6.6, and its length is B1, whatever that is. Okay, and that gives you a volume of 152 cubic centimeters. I'm going to drag this all the way across, and so that's going to tell me what my volume is. Now, all I need to do, now remember, I want to make the labels, the column heads, pressure and volume, so I'm going to actually do something, a little trick with spreadsheets. If you put something in bold, the computer will assume that that's supposed to be a label. So I'm going to click and I'm going to drag this all the way across. Alright, so I've captured all my data. And then if you notice this little picture here of a graph, I'm going to click on that insert chart thing. And you notice it's not really doing this the way I want it. And the reason is it actually thinks the rows are supposed to be columns and the columns are supposed to be rows. So I'm going to switch the rows and columns. That looks a little bit better, but it's not the right kind of chart for this sort of data. So what I want to do is I'm going to click on charts and I'm going to go to a scatter chart. And actually, it looks like maybe I need to switch it back. Chart. Start up. Okay, that didn't work. Let's go back to, I think actually I do want to, there we go. That's what it's supposed to look like. Now you notice that we got a really nice curve here, and then we get two outliers. Okay, that's not actually surprising. Okay, so what I need to do though is I do need to customize this a little bit. I'm going to customize it, and my title here is Boyle's Law. And I can even go a little bit further, temp 300K. Alright, and then we can do a few other things. I think I should be able to go with a legend. Let's see what else we can have. How about the x-axis and the y-axis? Let's see if we can do that, because axis labels. Okay, so the horizontal axis is pressure in atmospheres in ATM. Alright, and let's see, pressure in atmosphere, the axis, the horizontal one, and the left vertical is going to be temperature, volume in cubic centimeters. Okay, and we're just going to insert this, and boom, now we have our chart. And all we have to do, we're probably going to want to move it to where we can, so it's out of the way. But what you notice is this, except for these two outliers, and that does happen sometimes where you have some guys, some data points where you've made an error. Okay, but what you'll notice when you look at this is that you're actually at the higher pressure, the lower pressure, the volume is really, really, really high. It's up at like 400 at 0.75 atmosphere. The volume is like 400 cubic centimeters. So a lot of volume, low pressure. As the volume gets smaller, the pressure gets higher, which is Boyle's law. Okay, that's it for this first chart. All right, I want you to duplicate what I just did, and then we will move on to the next one.